Okay, now that we've talked about exponential functions, we're going to talk about logarithmic functions. And these are the inverse of exponential functions. So, our goal here is we're going to graph and identify the important properties of log functions. We're going to evaluate log functions, and we're going to solve basic exponential and logarithmic equations. This says to attempt to find the inverse of y equals 10 raised to the x power and y equals e raised to the x power. I'm going to tell you right now, the inverse of y raised to the 10th power, or y equals 10 raised to the x power, is log base x, or log base 10 of x. And then the inverse of e raised to the x power would be natural log base 10 raised to the x power. So, when we do a log function, b is greater than 0 and b cannot be 1. The base b is denoted. So it says f of x equals log base b of x, where y equals log base b of x if and only if b raised to the y power equals x. So this is very important that you know how to rewrite these. So this is the same thing as this. Notice the base becomes the base of an exponential problem. What it equals becomes the exponent, and then of whatever, it's what it equals when it's an exponential function. So some common logarithms. Base 10 is y equals log base 10 of x. Natural logarithm is the base e. Y equals natural log base e of x. So here's some examples. It says rewrite each statement in an equivalent form. So we're going to take the base. We're going to rewrite this as an exponential function. So this is a log. We're going to write it as an exponential function, which is what we did last time. So you take log base 2 of 16 equals 4. I'm going to rewrite it as 2 raised to the power of 4 equals 16. And if you think about it, 2 times 2 times 2 times 2 does equal 16, so it's a true statement. So I was going to take this next one. It become base 3 of 5 equals x, whatever x is. And sometimes you don't know what it is. But most of the time you're going to be able to solve them. Next one, log base b of 64 equals 3. We're going to say base b of 3 equals 64. All right, and we could solve for b. Right, b would end up being 4. We could also solve for x up here. 3 to the 5th power, you would type it into your calculator. Actually need to grab a calculator to figure out what that is. It's 243. So, you can always solve them. It's just you have to know how to rewrite it in order to solve it. Okay? So now we have exponential equations. We're going to write them as log equations. So this one, log base 12 of x is going to equal your exponent. So that's the same thing as this, just rewritten. Log base b of 8 is going to equal 3. See how this says base e? So now we use natural log instead of regular log base 10. And we would say e, but you don't have to write e, so you can just write natural log of 9 equals y. If it's a log function as base 10, we don't write base 10. If it's a natural log and has base e, we don't write base e. Okay? So, like here's some expressions and stuff like that that you could probably solve. I just want to take some and tell you how you would solve it. So I would say 2 to the what power would give me 1/8. Well, if you think about this, it's got to be a negative exponent to give you a fraction. So 2 to the what power gives you 8. Well, that's 3. So now I'm going to say it's 2 to the negative third equals 1/8. And you can type it into your calculator. Negative 3 would be your solution. Okay? So if you ever go from a base to a fraction, it's probably going to be a negative exponent. And vice versa, if it's from a fraction to a regular base, it's still going to be a negative exponent. This one as an example, 7 to the what power gives me 7? Well, that's 7 to the first, so that's why the solution is 1. If you have a log for the same base of 4, so this for example, it just turns into 1. So that's why it's 3. Okay, and the exponent's going to go out front. We're going to talk about exponent properties in the next lesson. So I'm not super worried about these as long as you can solve them. Now when it comes to graphing, we're going to do some stuff. So log base 2 of x, if you type this into your calculator, the way to think about this is that when you're doing this, log base 2 of x, your x value is 0, there is not going to be anything that would give me 0. Remember, this is the inverse of an exponential function. So if it was exponential, my y-intercept would be 1. Well, now your x-intercept is going to be 1. So you have to think about it in terms of that. And I'll show you what I mean on Desmos. So let's go to this. So here's a regular log function. Your base is 10. That means you're really essentially multiplying by 10. So instead of your y-intercept being 0, 1, now it's going to be your x-intercept. And it's going to be 1, 0. Notice, before, when we did exponential functions, it never crossed the x-axis. Log functions, they're the inverse, are never going to cross the y-axis. Right? And so when you're doing these, it's kind of hard to remember all the rules that go with logs. So the purple line, it's a base 2. That means I'm going to continue to go up by 2 on my x-axis. So in order to get to 1 on the y, I multiply my x by 2. And the next one would be 2 times 2, which is going to be 4. So they're always going to trail off to the right and never going to cross the y-axis. So if we go back to this, when x is 1/2, we can go look at our graph. X is 1/2, y is going to be 1, -1. Okay, when x is 1, y is going to be 0. When x is 2, 1, 2. So it's kind of like thinking about the inverse of, yeah, we multiplied by 2 before, now we're like dividing by 2. Okay? So notice there is no y-intercept. Your x-intercept is 1, 0. Your domain is no longer all real numbers, instead it's 0 to infinity. Your range, however, is going to be all real numbers. Your asymptote is now x equals 0, so that's like this line. It's going to be increasing from 0 to infinity, and there is no decreasing. So if I was going to graph this, let's see, 1/2, -1. 2. That's what it would look like. And as long as you know the general shape of a log is always going to look like that, you should be fine, because then you can do transformations from there. So now it says natural log and log, graph those. So if you graph both of these, notice they all have an x-intercept of 1. There is no y-intercept, they don't cross the y-axis. Natural log is very close to base 2, just not quite there. Right? So those are just some common similarities. They're always going to be increasing, stuff like that. Now log base 1/2 of x. If I do this, notice now instead of going up, it's going to be going down. So the base of 1/2 is going to be decreasing it, but the x-intercept is still going to be 1, 0. Now if I went to 1/2, I should be at 1 instead of -1, but now it's going to go to negative numbers. So we're going to do just kind of the same thing here. There's not going to be anything here. This will be 1. So our y-intercept, there is not going to be anything. X-intercept is 1, 0. Your domain is still 0 to infinity. Your range is still all real numbers. This is still x equals 0. It's not going to be increasing. Instead, it's going to be decreasing the whole time. And it's from 0 to infinity because it's based off your x value, which is the same as your domain. So if it has a base that's a fraction, right, it should be going down. If it has a base that's a whole number, it should be going up. So properties, your domain is normally 0 to infinity. Your range is normally all real numbers. Increasing, decreasing, just depends on your base of your log. If base is greater than 1, if base is between 0 and 1, then it's going to be decreasing. Your x-intercept is always 1, 0. Your vertical asymptote is always x equals 0. Now transformations, very, very similar to transformations we've done before. The a out front is a stretch or compression. Hopefully you remember it's a stretch if it's greater than 1. If it's between 1 and 0, it's going to be a compression. If your a is negative, that's a reflection over the x-axis. If your x is negative, that's a reflection over the y-axis. This is going to be left or right, but a negative h would be right. A positive h would be left because they're lying to you, and then your k on the outside would be up or down. If it's positive k, it's up, negative k, it's down. So this one, for example, I'm going to move everything right 2. And again, the good thing to focus on would be your x-intercept. So now instead of being at 1, 0, it's going to be at 3, 0. Okay? So as long as you can recognize the basic rules of a function and understand what's happening, you should be fine. This is a reflection over the x-axis. Okay, this is going to be left 1 and then up 2. And again, as long as you can do that, then you should be able to understand transformation. I'll show you some examples that you would see on Hawks. So they kind of give you a thing that you can go to practice. So exit this one. So the wrong one. Log functions. There we go. So for example, log base 6 of x minus 2. So you know it should be going up, like these 3. Minus 2 means I'm going to move it right 2. So I was at 1, 0. Now I should be at 3, 0. And that's the only one that's going to do that. So we know that one's correct. And as long as you know the general transformations, you should be fine. So same thing here. Log base 5 of x plus 2. I know my base is 5, so it should be going up and to the right. So I know I've got it narrowed down to these 3. And I'm going up 2. So it was at 1, 0. Now it should be at 1, 2, which is something like that. Because I didn't move it left or right. So your x-intercept is a key point whenever you're doing transformations. And there's only 2 of those, but they do help, or 3. They do help. This one, I'm reflecting it over the x, so it was going up. Now it should be going down, so I've got it narrowed down to these 3. All right. I'm going to move it up 4 and left 5. So I was at 1, 0. So now I'm going to move it up 4 and left 5. Should be this one. Except negative 4. So you should be fine as long as you know the general shapes of graphs. And we'll focus on the other stuff later on. Again, your homework's going to be like graphing, tell me the shape. And I really want to focus on, can you rewrite the problem? So as long as you know how to rewrite it and solve it, you should be fine. So again, same thing here. If I gave you log base 4 of 16, I said solve it. You got to think, all right, 4 to the what power gives me 16. So that's why the answer was 2. So that's why I have a solution of 2. You have to know how to solve these problems. 36 to the what power gives me 6. Well, that's bigger than this one, so it's got to be probably a fraction. Okay, so if I did 1/2, then I know half of that is going to make it 6. Because you're like dividing by 2 instead of multiplying by 2. In this case, you're dividing by the base. So it just kind of depends on the problem. And you'll have some practice with it on the homework. And the homework's just extra practice. It's paper again. Just make sure you get it done. If you have any questions, you can ask them. Be more than happy to help.